Radosław, thank you very much, first of all, for your time. You've been here with me. So Radosław, I am more interested to talk about the functional, the programming stuff, and we are continuously researching ourselves. We are continuously learning that what kind of frameworks and systems are being there. So I have by chance been interacted with Erlang almost 3 to 4 years back. So we are going to create a chat system, and everybody suggests what kind of platform we need to adopt. And then I find this eJabberD, maybe you heard about that. It's XMPP based chat solution currently used by WhatsApp. So WhatsApp is using.
Never heard about it.
Okay, yeah, no, it's no problem, because maybe somehow people know about that. So we have integrated this eJabberD solution. It's written in Erlang. So that was my first interaction with Erlang, but the language itself is not easy to adopt. So I think you have worked with Erlang before. So what's your opinion about the language and the system, this Erlang?
About the Erlang, I'm quite sitting on the fence, because there are parts of Erlang that I absolutely love, but there are also those that I hate. I think I like the overall ecosystem of it. The actor model is implemented in absolutely outstanding way. The ease of creating distributed applications is just amazing, and it's very satisfying. Like, I like the functional model of those distributed application, because communicating with messages, it's done so well that I'm absolutely amazed by it. But on the other hand, there's this front end side of Erlang where it feels very clumsy actually to use it. You can just feel that this language is like, I don't know, 40, at least 30 years old. The syntax is, I don't know. It is very tedious to write some basic things as for in a functional language. For example, like, I don't know, state management is done quite poorly. You have to pass the state around using variables. Scoping is absolutely broken. But I think the biggest downside of Erlang itself is lack of proper type system. It's something that really hurts when you make a bug and you have just no help of getting how it happened. For example, there's this dialyzer. I know that there's dialyzer that is sort of wannabe type checker, but it's so bad that I don't even consider it as a daily help. I think I like Elixir much more. It still has some problems that I mentioned, but they are less prominent. At least the syntax is much better.
Yeah, I think you're right, because I think I found Erlang as well. It's not easy to work with the with the syntax, because normally I have worked with most higher level languages and object-oriented programming like Java, Scala. I have worked with C, C++. So when I work with Erlang, is something very strange kind of syntax, and especially pattern matching is not easy to understand at first place. So you have worked mostly with core Erlang, or maybe you have worked with Elixir. What's your?
I have mostly Erlang experience. I didn't write much in Elixir, but whenever I had the opportunity to use Elixir, it was always much better.
Yeah, I think the most people, most new generation, most new developers, they prefer to work with Elixir more, or rather than Erlang. So I think it's I found Elixir is really good. The overall type system, they have very good top layer over Erlang, and they have a lot of libraries. They have very strong community now, and specifically for Phoenix web framework. So now I think web development is easier part when we are working with Alexa. But I found something this is what we have discussed in our as a friends, with my different friends and colleagues, that the syntax of Alexa is mostly adopted by Ruby.
Yes, and it's very much like Ruby.
Yeah,
Erlang adopts syntax from Prolog. which is
Yeah.
like from a jungle. So
You're right, yeah. So because it's 30 years old, yeah, almost 1980s. So Elixir is really good, and because the co-developer of Elixir, he's a Ruby developer previously, so he adopted most of the good features from Ruby, and it's easier to work with. But I think that's the question that we have discussed in our community as well, that why not Elixir is the major adaptation for the young people, for the young developers. They are not easily if you found, if maybe you are agree with my opinion or maybe not, that there are very less jobs for Elixir. If you found if you are looking to found Elixir jobs, you cannot easily find there. I don't know about your in Europe. Maybe you can share your experience that what's about
I haven't really been looking for an Erlang or Elixir job, so I can't relate to that. From my
that.
experience, like from what people wrote to me, the offers were mostly Erlang/Elixir. So it didn't really matter for the recruiters to like what language I know. Because I believe it's quite easy to convert from one to another because the key concepts of those languages is the same. It's just the syntax that's different.
Yeah, yes, and I think, yeah, you are right. And I think what I have found, I have researched about that, and most people, they have different opinions about the language and the ecosystem, and most people have figured it out, and they have mentioned that you if you need to work with Alexa, you have to first understand the Erlang ecosystem. Otherwise you cannot directly work with the Alexa, or maybe I don't know what your opinion about that, but this is the first thing that most people have mentioned about that you have to understand the Erlang, and then you have to understand the Alexa. You cannot directly get along. uh,
Okay, I think there's this little misunderstanding here because we need to put a clear line between Erlang as a language and Erlang runtime system. Like Erlang language is is just a programming language. You could technically compile it even to JVM if you wanted to. The real thing behind like Erlang is the runtime system and the actor model and the actor model, the way it considers processes and does the communication and everything. And I think this runtime system is what you really need to use Elixir. You don't really need to have some Erlang experience for that.
okay, that's good. You are right, because you have worked with the,
It's
yeah.
if I had to make a comparison, I would say it's like with when you learn Scala, you don't have to know Java, but you should know JVM, how it works. Yeah, it's this way.
Yeah, I got it. Yeah, I think this is most relevant comparison, I think. So yes, okay. I told you I have worked with the OTP kind of stuff with Erlang as well, like the processes and these kind of stuff, and for distributed application. How good that part is. If you want to create a distributed, we mostly always say about that. Okay, we have to create concurrent application and highly distributed application. How good the OTP part of Erlang is.
I'm not really the right person to judge it, but from my experience, it was very pleasant and straightforward to use. Although the documentation is quite bad on that, but I haven't worked with anything else to compare. I did some attempts to Akka in Scala, but those were just little local attempts. I don't have any professional experience, so I can't really tell how it compares with other things. But like from my I don't know only experience with that, I feel that it's well designed for that. Like I didn't feel there are any like conceptual holes in the idea.
Okay, yeah, I think so. Basically, I have previously worked with the Akka toolkit for Scala. Maybe you heard about that, or maybe not. It's the same actor-based model. They have figured it out in
Mhm.
for the JVM. So these concepts are very much similar to like Erlang, and they created this system by aspiring Erlang. So Akka toolkit is very good at it, structure model and these kind of stuff. So I have somehow figured it out that how Erlang have made these kind of system, and I think it's really good for distributed computing. We have a separate process, we have actor, and there's a completely immutable states, no shared state, no global state being there. I think that's real powerful features of
ITS
Erlang.
table switching table.
Yeah, because
So
people yeah, people came from, you have worked with object oriented programming languages, you
yes,
have. Yeah, so I think when somebody came for first time and I introduced some these things to some of my colleagues and some people in my country, so they are a little bit first, and their first behavior is something very strange, that okay, what is going on here? No mutable share state, no classes, nothing, and no structures. Officially there is no structure. They made it like pattern match kind of stuff, tuples kind of things, but there is no structures and classes, and no singletons. And I think for object oriented programmers, these things are a little bit strange. So but I think uh, as we are moving towards more future, I think functional, what do you say about that? I think functional programming is the future of the language, and it will completely dominate the object-oriented paradigm, or maybe not. What do you say about that? I think.
um, I think depending on the use case, because for the big distributed systems, at least from my experience, functional programming is superior because it's way easier to manage immutable state and make assumption, make this assumption that variables don't actually change over time is very strong. Like you can really rely on it, and it very much helps, I don't know, managing dependencies, writing tests, smoking stuff, and parallelizing computations. So for distributed systems, I believe functional programming is hopefully going to outperform, like replace object-oriented programming. But for some other cases, such as, I don't know, game development, I don't really see functional programming taking advantage over OOP, because OOP tends to be much faster if done right. And it models reality in more, I don't know, real way, let's say. First object-oriented languages were created to simulate, I think, ship battles. And this was the first use case and need for that, which I think for computer games is just the best match possible.
I
And
think.
also, I don't also like putting this, like considering OOP a counterpart of functional programming, because as we see in Scala, those two paradigms can go together. They're not contradict or opposite to each other. I would rather say that imperative programming is opposite to functional programming. So that doesn't need to be a choice between those two. You can take both if you design the programming language right. Yeah.
Yeah, you're right. I think it all depends on what kind of feature, what kind of implementation we want to achieve, and what kind of architecture we are building on. It's all there are so many parameters that we depend on. I think at the end of the day, maybe we need some type classes. I think that's the important feature, because how can we define, how we can make containers for data, I think. And Erlang, Elixir make like pattern matching. They have some kind of pattern matches kind of stuff. But if I need to create a container for data structures, maybe I have 3 or 4 data types and I want to encapsulate in one unit. So I don't have any option, or maybe I have some options, like
You have
structures.
records.
Okay, because I didn't, maybe I'm exploring things, yeah, because they made it like pattern match and everything. They don't have some kind of type classes, because I have most recently studied about F sharp. They have some kind of F sharp language by Microsoft, so it's more functional. They have defined some type classes, and you can make composable things like smaller types, and you can compose them into multiple types to create more structure kind of stuff. So I think that's the missing feature, that what I observe, that okay, somehow we need to prototype our stuff. So I think this is the missing feature, that what I found, that okay, Elixir have missing that, Erlang have missing that. Why not, if we can create a type classes? These are not objects, actually. They are not objects. They are some kind of data containers kind of stuff, like structures in C language. Yeah,
Type class is something entirely different. I wouldn't compare it to a structure in C, because struct in C is a type,
yeah.
essentially, and type class, at least those from Haskell and Rust, are some promises that some other type fulfills some interface, which is entirely different thing.
Okay.
And also type classes don't make sense without the concept of type. So in Erlang, you don't really have types. I mean, you can argue that you have, but you don't really. So I wouldn't see a use for type classes in Erlang. In Erlang, if you want to like mimic the behavior of type classes, you just pass behavior dictionaries manually, like it is done in Haskell implicitly. And then you can have everything type classes offer to you.
Yes, I think yes, this is something. Yeah, I have figured it out myself, and because the this little bit of strange thing that I found about Erlang, that there's a pattern matching kind of stuff going on here. So if I have 7 functions with the same name, but with different patterns of input data. So anytime I call a function, it will pattern match with the functions, and the most appropriate function will be called with the most corresponding parameters kind of stuff. So this is the behavior I think Erlang have, that you can define function with the same name, and you have pattern matches going on under the hood with these functions kind of stuff. So I think Alexa, well, what I found, that okay, if we can create if we want to create a top layer of Erlang, and which is already done by Elixir, it's really good. They did a really great job. I think they have already built a great system. So this is what our research project is about, that okay, if we want to create something on top of Erlang to make it simplify for young people, for young developers. So this is our research project. This is not something we we are discussing, that okay, because if somebody want to create a distributed application, he can just pick Erlang, and it's over. You don't need anything else. I think that's over. So what we are doing currently is we are creating a top level language of on top of Erlang. And what is the reason behind that? And the reason is that okay, let's make things simplify with the most modern features that most young developers will be easily can compare, that okay, these are the features I have already studied, and now we can implement the same features on how underlying Erlang is creating Beam, and Beam virtual machine, each and everything process, and each that stuff. But the developer that is working on top layer, he is comfortable to work with the most advanced features of functional programming. So this is our basically this kind of research we are working on. And whatever next, basically this leads to kit, like where you can create a web application, not web application, but some kind of JSON based database data applications on top of Erlang using our this actor lang model. So we have to first create a language, and then we have to create a toolkit like Akka toolkit been there, not a web framework, but the toolkit that you can integrate, and you can create a distributed application using underlying Erlang system. So I am just seeing about your profile and your experience, that you have previously worked with a compiler or maybe transpiler to for pure script, Erlang to pure script.
Yes.
Yeah, if you can share that,
Mhm.
what kind of project it was, and what you achieve from that project, maybe.
Okay, so our case was that we had some code base written in Erlang, which we wanted to run in the browser. And there's no really good way of turning Erlang to something that runs in the browser. So we just decided to write a transpiler to move, to just translate some parts of our code base into pure script. We chose pure script because it's a functional language that has built-in support for pattern matching and tail recursion and all the stuff that is necessary to mimic Erlang's behavior. And we succeeded in like most features of Erlang, that especially those that are sequential. I don't know what else to say. It just works. It produces very ugly but functional pure script code from almost any Erlang algorithm. But it's mostly designed for like sequential algorithmic code. It doesn't support any distributed stuff or hot code reloading or like all those dynamic stuff in Erlang. Nothing of those is supported in it. It's just for, we mainly wanted to transpile a compiler written in Erlang.
Okay. So basically this is pure script is more similar to like JavaScript kind of thing, and
no, pure script is similar to Haskell, but it compiles to JavaScript. It's essentially Haskell that compiles to JavaScript with some little adjustments, but
okay. So basically for that project, now you can write application in pure script and underlying it using the Erlang system somehow, or maybe something else.
No, it's that you write application in Erlang and you transpile it to pure script so you can run it in the browser.
Okay. So yeah, so it's a kind of backend application or something, or maybe it's front end related.
It's about moving from backend to front end.
Yeah, okay, I
I
got
would
it.
call it like that.
Okay.
I mean, it's not a tool for active development. It's a tool for migrating code.
Okay.
Because you wouldn't write in Erlang just to transpile it to pure script. You could have written it in pure script in the first place. Because our case was that code was written in Erlang and we wanted to do something with it, which is run it in browser, which is not possible with Erlang itself.
Okay, that's good. So, but you have experience with the compilers and transpilers, and I think this is our major area of interest that we are as a team we are looking forward that okay, if basically what we are going to create is in actual term, I think it's a transpiler we are going to create, because we are not compiling code somehow to Erlang bytecode, the Beam virtual machine bytecode. So we are basically what we are planning, because if we compile to bytecode, I think it's first of all it's not easy to compile to bytecode and then run it on the Beam virtual machine. And the second most important reason is that in the coming versions of Erlang, bytecode will be changed and our code will be broken, so it will not work in future. That's the problem, that we are not going to compile something to Beam virtual machine. So what we are planning to do is currently we are going to create a language which compile to Erlang language, and then so we will utilize the underlying Erlang Beam virtual machine compiler. So first it will compile to Erlang, and then we call the other compiler. So as far as I studied about compilers and these kind of, we have studied somehow in our in computer science subject, but that was its complete theory. The actual thing, I think what I have studied is that compiler is kind of thing that you are processing, which involve more processing of the strings. It's a kind of string processing. You're reading a file, you're reading strings, and then you have to tokenize something somehow, and identify the variables and types and each and every stuff, and then you have to create some abstract syntax tree AST kind of stuff. So you have to build some lexer and tokenizer, then parser and AST, and then you have to figure out how the program has been written. So we are figuring out what kind of language, what language we should use for the compiler. And so Rosa, yeah, I'm talking about that. Okay, we are trying to build a compiler, or maybe so-called transpiler for to compile our language to the Erlang syntax and language. So we are studying different languages, and so there are different people who have different background experiences with C and C++. You talk about Haskell. So I had yesterday I was going through the Haskell system and the compiler and each and every stuff, that if we are going to build something in Haskell, how good it will be. So because the ecosystem of the Haskell, it's completely functional programming, but I think I found the syntax a little bit strange, um, specifically how they define functions and the data and these stuff. But you can explain more better about Haskell, your experience.
I wouldn't call it strange. I would call it like pretty close to state of the art of functional programming, actually, because it's quite close to ML, which is, I don't know, sort of standard typed functional programming language, aside from Lisp, which is an entirely different story. You ask how good it will be. It's quite a tough question to answer, to be honest, because it depends on how you write it. I have pretty good experience with Haskell. For quite long, it has been my main programming language. So I spent quite a while using it for different purposes, including web development, compiler construction, and even some game development. And I feel it's quite hard to use it as a language that's supposed to have outstanding performance. But if you know it very well, you can absolutely achieve it. But a compiler, in my opinion, doesn't have to be done fast. It is more important that it processes the compiled language nicely, and it's expressive in terms of data manipulation. And I think type system of Haskell is very powerful and very helpful, especially in terms of working with artificial languages. Mainly because it's data structure system, which is based on algebraic data types, and language constructions are usually expressed in a way of some kind of algebra. You said you like type classes, which you have in Haskell done in a very, very extensive way. There are lots of features of that which can be further extended to with some other magics. And yeah, I mean, I wrote at least 2 compilers and one quite complex interpreter in Haskell, and the experience was just amazing for that. Some people also use OCaml for compiler construction. I think this language is nice as well, but Haskell is very, very expressive. I would say it's more expressive than OCaml in terms of, I don't know, things that it can do implicitly and take care of, especially with how it utilizes monads. It is bizarre for a person who hasn't programmed in it ever, or in any programming in any functional language, but I wouldn't say the barrier is set very high if you already know some functional programming.
Yeah, I think
Yes.
I think we are continuously exploring different functional programming language, and hopefully we will explore this Haskell as well, specifically for building compilers or maybe transpilers something. So we are only worrying about 2 or 3 things about when we are building compilers. I think portability is one of the issue that, okay, we have to port our compiler to three major operating system for Mac, Linux, and Windows. These, and you have already told that, okay, it can be portable, and we have to check these things further, that, okay, because compiler should be available for all the major operating
Yeah, of
system.
course.
Otherwise you cannot include, you can say, open source contributors from all around the world, because we cannot limit things to Mac or Linux or something. So Windows is a very huge market share. So this is one of the thing we have in mind. Maybe.
But I
And
think most of the languages that you're going to consider should work fine on all three operating systems you mentioned. I don't see why it would be harder to or impossible to compile on, I don't know, Windows or Mac or Linux or whatever. All those languages are open source, and they are you can even compile the compiler on your own.
okay, yeah, you're right. I think so. So we have to build a program, a compiler program, and we have to compile it on. We have to go to the every machine, and we have to compile there. For example, if I create a compiler for in Haskell, and I have to use it on Windows, so I have to take my program to Windows, and then I have to compile it, or maybe I can do it for some other operating system. What you say about that?
If you write the compiler in Haskell, you just have to compile it for Windows, and it will run on Windows as any other application.
But I have to use Windows machine, Windows operating
I'm not
system.
sure. I think you can compile to Windows from Linux, but I've never done that, to be honest. But I compiled Haskell on Windows, on Mac, and on Linux, and I never had any problems with that. And it was the same code that compiled everywhere.
Yeah, I think
But
that that's
you just need separate builds for every operating system. But I think it's pretty normal for any compiled language.
yeah, I think,
Aside
yeah,
from
you're right, because every language you can compile it on, because we have so many compilers available for so many languages, and every compiler have their own operating system. So it's a different compilers for different operating system, and we can use that. So yeah, I think it's a continuous research process for all of us, and this is the interesting part, that, okay, we at least, if even if we don't reach somewhere, but at least in this whole process and whole journey, we are going to explore a lot of different functional programming languages, and whole programming functional domain, as an ecosystem, that, okay, how functional programming will help us to build more stable uh, applications. So this is part of our research process, that, okay, let's build something and explore each and every programming language. So like Haskell, you talked about Ocmel, and Scala we have already covered. We have different people from Java and Scala background, so they we so our purpose is to explore the different programming languages in this domain, and we want to get useful features from the functional programming languages.
so in that case, I don't really see why you consider C++
Yeah,
use option.
you're right, because in fact, I tell you this story why we choose, because most of the people, and in my group and my community, they have at least studied C and C++. They are from CS background. I don't know about education system in your country, but in my country, every academic, they have include these three languages: C, C++, Java. So everybody have this background. So I think if I tell them about Haskell or something, okay, let's build something, so they will need more time. So this is you can say it's a, if you think about low level, so these are the most obvious choice, and this is what I have studied, that, okay, most of the interpreter, if you know maybe about that, PHP and Python, they are written in C language,
Oh,
somehow C++.
I mean, there's a substantial difference between an interpreter and compiler, because interpreter has to be fast, because the how much an interpreter is fast that is the same how the language is fast. Yeah. But compiler, it just has to process a string, as you said, and spit out the result. And it doesn't matter if it takes, I don't know, a few seconds more to do it. It's more important that the resulting code is efficient. And it's much easier to apply optimizations in functional languages that use more abstractions, of course, at cost of performance, than in a language like C, which is definitely not designed for compiler construction. I haven't written a compiler in C or C++ myself, but I've written some C and C++ at the university and on some other opportunities, and I would never take it as a compiler construction language because of its convoluted type system, which doesn't really conform to the standards of defining grammars and working with and defining semantics. And also memory safety is a concern that I don't want to have while writing a compiler. It's not a program that is going to race against others.
You're right. I think memory management is the important part. Yeah, you're right. Because if you miss, especially last time we were experimenting something in C++, and we have to finally find that we have to deallocate the memory as well. So you have to, if you have allocating something, you have to manually manage each and everything in C++. Otherwise, you will run out of memory because compiler will continuously compile. Every time you compile, it will allocate something, and at the end of the day, if you compile 100 times, you have to restart your system. So we have to be very careful about this part, I think.
Actually, that doesn't work this way, because if the compiler terminates, all the memory, even that not deallocated, is wiped out by the operating system. So it's not the issue. The issue is more problems like undefined behaviors, such as use after free, or I don't know, dangling pointers. Those are dangerous during the execution because you can have unpredictable behaviors and you won't get warned about it. Maybe by some Valgrind utility, but it's generally not a concern you want to have with a compiler. And also, like the type system of C++, I think it would make it harder and less readable to write a compiler in. Because C++ is object-oriented.
Yes.
Let's make it clear. And object-oriented languages treat data as some entities that behave, that do some stuff, which doesn't really match constructs in a programming language. Constructs in programming language are more data that is manipulated from the outside, which is the approach that functional languages take. So I would rather see, for example, Rust in this role. If people in your team like imperative programming, maybe Rust would be a better option. It's not functional, but it treats data as functional programming, as functional languages do.
Yeah.
And there are some compilers written in Rust. And I myself didn't write a compiler in Rust, but I have a friend who did, and he really liked it. And I read his code, and it was very clear and very nice compared to C++ compilers that I read, and it was disastrous, at least to me. Maybe I'm biased, but this is my opinion on that.
You're right. Somehow we have found that ourselves that it's not easy to write software in C++. It's have very different kind of types, and it's object oriented, and maybe I think we don't have to use the object more objects in compiler, I think, because we are not building the whole application. We are building something that is processing some strings and these kind of stuff. One of the shortcomings that maybe I've found about this in functional language, that we cannot, maybe you notice that we cannot return earlier from something. Everything is a function. Functions are first class citizens. We mostly hear about that. Everything is a functional value at the end. We can define functions that don't return anything, but most of the time we define something that can return a value. And I think in terms of when we talk about compilers, uh, if we found, I think the compiler major purpose that if it's found some error, something, we have to immediately stop the program on that point. We should not proceed further. Immediately report that to the user that, okay, this type is missing on some line, something, for example, some line number 10, this variable is undefined, or this type is undefined, there is some error. So what you'd say about that? I think this early return phenomena is not found in functional programming. You can't return, or maybe.
Well, I see a point in here, and I would say that, well, if you have many type errors in your program, would you rather see just the first one or all of them in the error log? I think you would like to see all the errors. So the strategy you take there is, when you see a missing variable or some type error, you do just anything to produce some result for further type checking or processing or whatever. You log this error, you keep it, and you just proceed. And at the end, you check. In the end, you check if there are some errors reported, and if there are, you just report them all. So the compilation process does not stop on the first error. And it's something you have to keep around in some environment or state behind the scenes. You just add an error to the log and you go further in search for other errors. Yeah, because you don't want to display just one error if there are thousands of those. Yeah. So Haskell does it nice, because you have this state monad which allows you to keep some certain mutable state behind the scenes. Of course, it's not mutable, it's just some monadic trick to carry it over. And you can just put some stuff in that. And in the end, you can just take it out and see if there were any errors on the way. So there are mechanisms to deal with that, and I feel they are very clean, and they are very also easy to test. Like they are very testing friendly. So I would disagree that there's some mismatch here.
Yeah, I think you're right. For the whole program, if you are compiling multiple files, I think you're right, because we have to inform users that, okay, these are all the errors in the program. I'm just talking about that you can say there is one part with every compiler that, okay, you have terminal, and you can just compile part of the application, like just a single expression here, like you see in Erlang as well. Erlang have some kind of compiler interpreter there in terminal, so you can just open the terminal, you can provide some expressions, or maybe you can provide single file, and then it will immediately compiling that part. But for the whole program, you're right that we have to inform user at the end that, okay, these are the 10 or 20 errors in your code, please fix that. And then, because otherwise it will take a lot of time for the user, that every time he come back, a new error been there, and he will just stuck to figure out every time he have to run the program again. So yeah, I think that's fine, and we are continuously looking forward that what is the best way, because this is some kind of research work for ourselves, how is the best way to implement these kind of system. And I think you have a great experience in this field, and we will keep, I think we will keep discussing with you in future as well. So
but I'm interested in distributed systems and automated verification of them.
That's I think that's part of our research project as well, because we as far as I'm continuously working with the backend system, and this is our part of our interest every time, that create some high performance distributed applications. So how we can create that. So this is part of in multiple companies I have worked with different projects, and we have always keep discussing that, okay, what kind of backend system, and what kind of database we are adopting something. So like NoSQL is more popular in memory databases, so we are focusing ourselves like in memory database for creating high performance application, and it should be distributed, it should be fault tolerant, and these kind of stuff. So continuously we are working. So I will Thank you very much for your time, and I will everyone of us here, I will keep connect with you. You are doing maybe hopefully you are doing great research in future, and we will keep sharing with you everything that okay. If you can contribute, you can help us in future to develop these
Of
kind of
course.
system. Yeah, I will keep connect, and I need more contributors, more people from all around the world, from tech communities, to see that, and maybe hopefully we need more support for that. So thank you, Allah. Thank you very much for your
Yeah,
time.
no
Thank you very
problem.
much. Yeah.
It was nice to meet you.
Yeah, nice to meet you. Thank you very much for your time.